Welcome back to TigerPaw Academy. Today we're going to be studying section 6.1, sequences as discrete functions. So we're going to start out with the definitions, and then we're going to move on to some key concepts and end with the examples. Let's get started. The first definition is going to be a sequence. So a sequence is a list of numbers or a sequence of numbers with a set pattern which can either stop at some number or it can continue indefinitely. So with this first sequence, 3, 7, 11, and 15, the set pattern is you add 4 to the previous term, and the sequence will stop at 15. In this second example, we have 2, 6, 18, and 54. The pattern is you multiply the previous term by 3, and it continues indefinitely, as shown by the triple periods at the end of the sequence. A sequence is also a function whose domain is the term number. For example, term 1, term 2, term 3, and term 4. And the range is the actual term. For example, term 1 equals 3, term 2 equals 9, and so on, and so on. So the term of a sequence is a single value in a sequence, as shown here. The explicit formula is a formula that relates the value of the term to the term number, n. A continuous function is a function whose graph has no holes or jumps and is shaped like a curve. So that means all the points are connected by a line, and the function could also have the point in between the major points that you probably already marked down. Now it's important to note that in a continuous function, there are no imaginary numbers. So that means the graph will map real numbers to real numbers. The final definition is a discrete function, or a function whose graph is made of separate points. Now this graph is different than a continuous function. As you see here, there are only separate points on the graph as explained before. Now let's see some key concepts. Okay, so some of the key concepts are discrete function, which we already explained before. The next key concept is the domain of a function representing a sequence is the set of the natural numbers, and this is represented by the stylized n, which is similar to the e you use to describe x could be any number in a domain. Given the explicit formula for the nth term, t of n or f of n of a sequence, you can find the term by substituting the term number for n. I'll make this clear with an example. So here we have the equations Tn equals 3n plus 2 and Fn equals 5n plus 3. Here we're going to be substituting 6 in the place of n. So here we have term 6 equals 3 times 6 plus 2 equals 18 plus 2, which equals 20. Therefore, term 6 equals 20. Here we have f of 6 equals 5 times 6 plus 3, which equals 30 plus 3, which equals 33. Therefore, f of 6 equals 33. Finally, we're going to learn how to determine an explicit formula by using the first differences. So here we're going to be using the sequence 7, 12, 17, and 22. So the first thing you're going to do is find the first differences. So the first difference here are all 5. You're also going to draw a graph so that you know which equation that you're going to use. In this case, the graph is a function and it is linear. So the explicit formula will be in the form f of n equals mn plus b, where n is substituting for y. Since the rate of change is 5 and b equals 2 by inspection, the explicit formula will be f of n equals 5n plus 2. And that is all for section 6.1. I hope I helped.